In this lesson, we're going to use the intermediate value theorem to help locate real zeros of polynomial function. Intermediate value theorem. The intermediate value theorem. If f of x is a polynomial function with only one real coefficient, and if for real numbers a and b, the values of f of a and f of b are opposite in sign, then there exists at least one zero between a and b. In this example, we're asked to evaluate the function to show that the function f of x equals x cubed minus 2x squared minus x plus 1 has at least a real zero between 2 and 3. So to determine whether there is at least a zero between the values of 2 and 3, you would have to evaluate both of those numbers. In other words, into the given function, you're going to find f of 2. You're going to plug in a 2 everywhere you see an x, do the math, and see what your output is. You're going to also do that for 3, find f of 3, do the math to see what the output there is. Now you can either do the math by hand, or you can also use your calculator as well, whichever is you prefer. Let's go ahead and plug in the first one to find f of 2. Again, that's plugging in an x everywhere you see, plugging in a 2 everywhere you see an x. So once we evaluate that, you're going to multiply the number 2 3 times. That's going to give you 8. And then if you multiply the number 2 twice, you get 4. Then multiply that times negative 2. And then you have a negative 2 here in the back plus 1. But go ahead and do the math. And what you should get, I can give you some time to go ahead and plug that into your calculator or do the math by hand. The output of evaluating f of 2, what you should have gotten is a negative 1. So we got a negative number out. Now we need to evaluate f of 3, and once we do that, if we wind up getting a positive, then that would be opposite signs, because we just got the negative for our first evaluation. Now if we evaluate the second value and we get a sign that's opposite of a negative, which is a positive number, we don't care what the number is, but if that number is positive, then that is your proof by the intermediate value theorem that there exists at least one zero between these two values of 2 and 3. So I'm going to go ahead and plug in a 3 everywhere we see an x into the function. And you're going to go ahead and do the math the same as you did before. You're going to multiply the number 3 times. That's going to give you 27. Then you're going to multiply the number 3 twice. That's going to give you 9. Multiply that with negative 2. That's going to give you negative 18. You also have negative 3 back here and then plus 1. So in doing the math, what you should notice is that you got an output of 7. And since that number is a positive, the first evaluation we got a negative out. The second time we got a positive out. And when you evaluate both values, if they are opposites in sign by the intermediate value theorem, it means that there exists at least one zero between those two numbers. So there is our proof that yes, there is at least one zero between 2 and 3. Let's do another example. Evaluate the function to show that the given polynomial function has at least a 0 between the values of negative 4 and negative 5. So you're going to evaluate both values. You first evaluate f of -5, plug it into the function to see what your output is, and then find f of -4. So starting with the first value of plugging in a -5 and proceeding with doing the math. Again, you can use your calculator or you can do it by hand, whichever you like. And I want you to tell me in terms of your output, and we actually don't even care what the number is. We just need to know if it's a positive or a negative. Because once we do both of these values, if they are opposites in sign, the outputs from these evaluations, then that is our proof that there is a zero between -5 and -4. Now, if the signs are the same in the output, then there is not a real zero between those two values. Okay, so you should have had some time now to get your value, and your output for this should have been a -18. Now go ahead and do the f of -4, and I'll give you a little time to plug that in, either manually with your pen and paper, or you can do it with a calculator, whichever you prefer. We just simply need to know what the sign of the output is. Okay, so in evaluating f of -4, what you should have gotten out is a positive number, and again, the signs are opposite. You have a negative and a positive, and that is your proof that yes, there is at least a real zero between those two values of -5 and -4, and that's the intermediate value theorem. Okay, now before we close on this lesson, I want to go over another method for determining whether there is at least a real zero between two values. Now, if you are in pre-cal class, for some reason in your textbook, the intermediate value theorem comes before learning synthetic division. So if you don't understand what I'm doing here with the synthetic division, don't worry. Just go ahead and evaluate it by plugging it into the function. But those of you who are in Mac 1105, the college algebra, synthetic division does come before, as it should, before learning the intermediate value theorem. So you are already familiar with how to use synthetic division to divide polynomials. All right, so again, as I stated before, for those who are in pre-cal, you can just follow along and don't stress yourself again if you're just not familiar with it. You can wait until the next section, which is section 2.4, and then I will go over in detail how to divide using synthetic division. All right, so in dividing using synthetic division with the two values, they are going to be your divisors. So we're given the polynomial here, and we're going to first evaluate it for 2, which means 2 is going to be my divisor on the outside. So with the synthetic division, remember, we don't use the x's, we only use the coefficient. So if the coefficient of the first term is x, coefficient of the second term is -2, coefficient of the next term is a -1, and the coefficient of the last term is a 1. So we're going to go ahead and place those or set up our synthetic division with the 2, the divisor being on the outside. Okay, so recall step 1 is to bring down your first term. So we're going to bring down the 1, multiply that with the divisor of 2 to get 2. Combine those terms, bring down a 0, multiply that with 2 to get 0. Combine those terms and bring down a negative 1. Multiply that with the divisor of 2 to get negative 2. Combine those terms and bring down a negative 1. So the remainder is your output there. We have an output of negative 1. So that means that f of 2 equals negative 1. Now we're going to do the same thing for the second value we were given, the value of 3. That's my divisor. That's going to be on the outside. The same values that are going to be underneath our coefficients there. And again, we start by bringing down the first term. So we're going to bring down a 1. Multiply that with 3 to get 3. Combine those terms and bring down a 1. Multiply that with 3 to get 3. Combine those terms and bring down a 2. Multiply that with 3 to get 6. Combine those terms, which means I'm going to bring down a 7. Our output here is a positive number. For the first one, we got a negative number. So recall by the intermediate value theorem, if the signs of the output are opposite in sign, then that is proof that there exists at least one 0 between 2 and 3. Okay, your turn. This is just practice. I want you to determine or show that this function, the given function, has at least a real 0 between 4 and 5. So what you're going to have to do is, if you're going to use evaluate that function f of 4, then do it again and evaluate f of 5. And if the outputs are opposites in sign, then yes, there does exist at least one 0 between them. So you're going to see where that fits in terms of A, B, C, or D. And then if you're using synthetic division, you're going to remember for synthetic division, you're going to use only the coefficients in terms of underneath the division symbol. And the outer number, the divisor, is the number that you're evaluating. So you're going to evaluate it first for 4. So 4 will be on the outside the first time you do it. Then you're going to do it again with 5 being on the outside. And again, if those outputs, which is in this case, it would be your remainders, if they are opposite in sign, again, there is your proof there. So go ahead and do that, and I will give you some time. You can stop the video, and then when you're ready to reveal the answer, go ahead and restart the video. Okay, so whether you did the evaluation way where you plug the values in and manually calculated, or you plugged it into your computer, that's called the first method, which is evaluating the function. For those of you who are in college algebra, you should be familiar with the method of synthetic division. So in using synthetic division, if you notice that your outputs there, again, if they are opposites in sign, then that's your proof. So I'm going to just show real quickly the synthetic division way. So those of you who didn't do the synthetic division, no worries, no stress. You still got the same outputs. Whichever way you did it, you should have gotten output for f of 4 is -2, and f of 5 is 45. So that goes with A of f of 4 was an output of -2, and that is less than 0. And f of 5, you got an output of 45, and that is a value that is greater than 0. So again, by the intermediate value theorem, that is your proof that there is at least one 0 between those two values. So I want you to see it this way as well, because you may see it on the test in this form as well, to where you're choosing whichever statement is the true statement. Let's do another example just to make sure we got this. So again, I want you to, okay, so let's do one more. Just want to make sure you got this intermediate value theorem. Now be careful on this one if you're doing the synthetic division, because as you see, the first degree here is a degree of 4, then it goes to degree of 2, and then to 0 degrees. So they're not, you don't have all your degrees there. So if you're going to do synthetic division, you're going to have to put zeros in there as placeholders. You're missing the degree of 3, so you need a placeholder there. You're also missing the degree of 1, so you're going to have to put a placeholder there of a 0 as well. Now, those of you who are using the evaluating function, you don't have to worry about that. You just go ahead and plug in those values in place of x and do the math and see what your output is. But for those of you who are doing synthetic division, be careful there and make sure you insert those zeros for the missing degrees. When you're ready to reveal the answer, go ahead and restart the video, and then we'll reveal the answer. Okay, so what you should have gotten there, yes, the signs were different, so there is at least 1 0 between those two values. Now, in determining which one of those statements was true, it was, again, A, to where f of -1 was a value that's less than 0, and f of 0 was a value that was greater than 0. So again, because one was negative and one was positive, there at least exists at least a 0 between those two values. And there you have it, the intermediate value theorem. Okay, that's it for this lesson. Thank you for watching MVP Tutorials by your instructor, Dr. Speights. I hope you'll join me in the next lesson. Please feel free to like, share, and subscribe. Goodbye for now.